Good afternoon. You guys are enthusiastic. Yeah? I'm the only one between you and the party. You realize that, right? Is that the only reason you're here? No?
Is everyone going to the party? Yeah?
No?
Okay.
Okay.
Few of us.
We're here to talk blockchain. Forget all this party stuff. Okay. I'm Richard. I'm based in Singapore. Work as part of the black belt team. That shows off my karate skills. That's a demo later on. But we're here to talk about blockchain. Blockchain's fairly new. Microsoft's doing quite a bit of stuff in this space. Before we get started, show of hands, how many of you have heard about blockchain? Wow, okay.
Oh, okay.
How many of you have an idea of what blockchain does beyond Bitcoin? Okay, great. Okay, we'll keep it fairly balanced. We've got a few demos around what you can do with Microsoft and how you can get started. We've got some initial slides that level sets everyone in terms of what is this blockchain protocol. So with that, let's do myth busting. Okay, blockchain is the name of the specific database technology behind Bitcoin. Okay, Bitcoin's become pretty popular. Blockchain has become popular because of that. Essentially, when people talk about blockchain, they're talking about these attributes. They're talking about distributed systems, peer-to-peer, from the world of torrents. How do I have a distributed network of nodes so that there's no central authority? They're talking about how do I have a secure platform, something where I can exchange value or exchange something of trust between two parties or multiple parties who don't trust each other. It's a ledger. It's like our bank statements. There's no update, there's no delete. Everything is a single transaction. And then most importantly, it needs to be shared in order to get value. A hospital taking all of its patient data and putting it onto a blockchain, great. They're probably digitizing their platform, no value. Value comes in when that hospital opens up to an insurance company. So now you can think, right? We have a shared system. We've got some data being shared between a hospital and an insurance company who don't necessarily trust each other, but here's a system, here's a platform for them to trust each other. And guess what results out of that? Faster claims in the insurance space, right? Insurance companies linked to that hospital, any claimant, go in and, or a policyholder, go in and processing claims, it becomes much more faster. Customer satisfaction increases. So things to think about is, who do I share this ledger with? Because that's the real value. Okay? So we've established a few things. Bitcoin, popular, blockchain, that specific technology behind Bitcoin. Essentially, when people talk about blockchain, they are talking about distributed ledger systems, right? We say blockchain because now we're in the world of words like blockchain and cognitive and not three-letter acronyms like IoT, right? And so that's why we stick with blockchain. What else? There are other protocols, other distributed ledger protocols like blockchain, Ethereum, Eris, multi-chain, open chain. Our friends at IBM are developing something called Hyperledger. These are all distributed ledger protocols. They work in a few different ways, but they essentially have these four characteristics. Okay? So let's dig a little deeper, right? So essentially when we talk about a ledger, right? We're all used to a traditional accounting ledger where we have transactions. We're now talking about a ledger that is spread across multiple nodes, right? That brings the distributed nature. Gee, it's difficult to see the screen from here. I'm going to go here. And so this ledger obviously records transactions. And transactions are between a source, a destination, and we're exchanging something of value, right? The blockchain or the distributed ledger database need not hold every piece of information. So this is where we start introducing you concepts called on the chain and off the chain. On the chain refers to data which you're putting on the blockchain. So maybe basic details. Who's the source, who's the destination, what am I, what kind of information am I transacting and what is that information or what is the value of that? All the rest of that information pertaining to source A, pertaining to destination B, pertaining to what is being exchanged, that could be held in your CRM system. That could be held in your distributed database system off the chain. So on the chain, what are you keeping on the blockchain and what you're sharing between parties versus off the chain, which you're maintaining locally. And that's important. It's important because now customers or different organizations feel much more secure in sharing just enough information to get the job done. without revealing everything that you need to know from a personal identification perspective. Okay? So essentially, it's a huge ledger. It's distributed. It's shared across all these nodes. And these nodes are nothing but machines. These machines, most of them, run Ubuntu or Linux or some sort of open source operating system. And then there's a protocol which exists on top of it. So we talked about blockchain. There's Ethereum. There's all of these different protocols which you install on it, and this node becomes part of the network. Any one of you could go and stand up a node. If you're looking at Bitcoin mining, that's what people do. They go and stand up a node, they join the network, they do some sort of mining, in terms of these transactions, and if they do happen to mine successfully, there's an incentive in it, right? So people are maintaining this node just to keep awareness of what those transactions look like. So what are these transactions, right? Every block, as the name suggests in blockchain, is tied to the previous block. It all goes back to what is known as the Genesis block. Each block contains transactions. As you saw on the previous slide, there's a source, there's a destination, and there's something of value which is being exchanged. All of this is represented as what we call a digital identity. So a source has a digital identity, a destination has a digital identity, what they're exchanging of value has a digital identity. Bring all of those together, that becomes a digital identity. Essentially, it's a big string of numbers. That gets represented as a transaction on the block. A block with a number of transactions is essentially transactions that have taken place at the same interval of time, right? Or maybe at 5-minute intervals, depending on the protocol you're using. When a block is full of transactions, which means that in that 5-minute interval, I've captured all of the transactions I've done, the block is capped. What does that mean? Is that there is like a linked list, right? There is a starter pointer and an end pointer. The block is capped, and then the full block also represents a digital identity. And that's a transaction which points to the previous block. So it's a continuous chain of blocks, each holding transactions that point back to a Genesis block. That's probably the only thing you should remember from that slide if I've confused you, okay? And so what happens when we've got this distributed ledger system? It's these blocks, these nodes which have got these transactions. It's essentially removing a central authority, right? So gone are the days when, if you take the insurance space again, where in Australia, the RBA works with LIBOR, works with insurance companies, and they all go through this massive workflow in just processing a claim. If I have now a decentralized authority where everyone is collaborating and has access to that information, I could get things done much faster. But there's a problem. Or rather, before we get to the problem, benefits of decentralization, right? I put this up, fairly easy to understand. It gets rid of the middleman. If it gets rid of the middleman, the chances of fraud, the chances of counterfeiting, the improvement in processing, the improvement in operational efficiency, all of that increases. But then again, when you remove the middleman, you've got a few issues over here, right? Who's the boss? Who's maintaining ownership? Who's the one who has the authority to say? And this has been a fundamental problem when it came to exchanging anything of value or trust over the internet, until this identity, right, or a person or a group, whichever one you want to refer to as, Satoshi Nakamoto said, we could solve this with cryptography. Right, so we could build this distributed ledger system where we take every person as a digital identity and we use cryptography and we build authenticity and immutability into this ledger. And that's how Bitcoin came about. So people go like, oh, okay, wow, this actually works. And so those are the 4 characteristics around shared, distributed ledger and security that came about with distributed ledger systems. That's from a high level. Let's go one level down. So I use the word identity a lot, a digital identity. So how do we come about with an identity? So let's take us, for example. So we human beings, we're represented in each of our countries by our name and probably some sort of identity in terms of social security or permanent residency number of some sorts, right? If I take that identity and add in multiple other inputs to it, inputs like maybe a username, maybe biometrics, maybe some passwords, it tends to be unique to me. I take that and put it through a mathematical hash. So we all know a hash is a one-way formula. You give it the same inputs, it's going to produce the same output every time, right? That's how I get an identity as a person. I could do the same thing with an asset, right? Whether it's a part of a phone, whether it's part of a car, they all represent something. Most of them have a serial number. I take a serial number plus a manufacturer. I take a serial number, a manufacturer, and a model, right? Try to make them unique. Again, I put that through the sausage machine, and there I've got an identity. The identity of all the parts that make up a phone, if I take all of those and put it through a hash, that becomes the identity of the phone. So basically, everything in that way can be represented as an identity, okay? So I've got this identity. What do I do next? Now I need to do something on a transaction basis. So here we've got who? Alex and Katie. They want to exchange some money. So Alex has got an identity of some sorts. Katie's got an identity. And that's what that transaction looks like. From a big string of numbers to another string of numbers and something of value, in this case currency, being exchanged. I take those three attributes, I put it through my hash function, and that itself represents an identity. So what do I do now? So let's say Alex wants to send Katie some money. It gets put into a transaction. This transaction gets broadcast onto the blockchain network. So remember we said how we can all be part of this network by being a node, and a node being nothing but some OS with a blockchain protocol that we're participating in, and we each have a copy of the big ledger. That's what happens. This transaction gets put out onto the node. It's like broadcast in the world of networking. All of the different nodes look at this transaction and go, okay, let's do some checks here. Let's go and check the identity of the source, the identity of the destination. If that source is sending to this destination something of value, well, that source needs to own it in the first place, right? Do some verifications then. Once it's been through that, that transaction is taken and put onto a block. And this happens, right? Multiple transactions happen, they get put onto the block until we reach that 5-minute period, and then the block is kept through a process called mining. What is mining? Again, come back to the nodes of the network. These guys play a guessing game, right? So not to confuse you too much, these guys play a guessing game of what is going to be the digital hash of all those transactions in that block. So they know that, okay, this block has got like 100 transactions. If I take those 100 transactions and put it through a mathematical function, it's going to give me this digital identity. So they've got the answer, which is the digital identity. They know how many transactions there are. They've got to guess what's that input, or what is the combination of inputs. And the first one who does it is, in the world of Bitcoin, he gets an incentive. In some other cases, they don't get anything. They've just used a lot of CPU and processing power, right? But essentially, that block gets capped. When that block is capped, it points to the previous block, and a new block starts, and we do the same thing over and over again. Different protocols, the time it takes to do this varies. So if you look at Bitcoin, we can do about 6 transactions per second, right, in terms of mining. It's important. Why? Because today a lot of people go, oh, we're going to solve world peace with Bitcoin. Fantastic. Visa does 40,000 transactions per second. NASDAQ does 100,000 transactions per second. Banks are talking about doing Bitcoin. 6 transactions per second, right? So we've got to be real, right? We've got to see where are the use cases when we're talking about some of these technologies. And that also determines the choice of protocols we make, right? There was another protocol called Litecoin, which came and did 600 transactions per second, based off Bitcoin, but as the name suggests, a lighter version. There's other protocols called Ethereum, where they don't do so many transactions per second, but they offload it to another system, right? So use case, when we have those requirements, we've got to figure out, what's the protocol we need. The other thing about a blockchain is that it's never, it doesn't ever contain static information, or it never contains the total value. So for example, you would think, okay, if Alex has transferred money to Katie, and then Alex has transferred money to John, and John's transferred money to Katie, great if there was a table which showed, at each point of time how much was the total value. So every time someone's transacting something of value, it's tracking all the chains. It's going back and tracking, okay, at that point of time, Alex sent something to Katie, and then Alex sent something to John, and then Katie sent something to someone else. It's tracking all the chains each time it's doing a transaction. And that's where ownership comes into play. So far I've talked a lot about financial transactions. Sorry.
Oops.
Jay's trying to Okay, so far we've talked a lot about financial transactions. That same concept of source, destination, exchanging something of value, and the way it's represented on blockchain, I can now extend into other use cases. So now I want you to think about ownership. So I have a car, right? That car is represented by an identity. I've purchased it. I sell it to someone else. I've transferred ownership. That person sells it to someone else. He's transferred ownership. That car is probably destroyed, gone back to a yard. They've taken those parts and rebuilt it into another car. I can track ownership. And the same concept of how I track transactions on a blockchain, I can now do that from an ownership perspective. So what comes out of this? So if you think of it, right, if you eat a salad, right, and you're bought into the whole organic thing, and so you say, okay, great, this salad is organic, and how do I know that? By reading the label behind. And I swear that because it said it's organic, it's organic. Well, how do I track it? So John West, I'm sure you're familiar, the tuna company. If you go buy a can of tuna and you look at the barcode behind, there's a little website. You put that barcode into that website, it tells you the tuna that can of fish came from, right? Consumers are demanding this. Consumers want to know that salad, right, where did those tomatoes come from? Where did that cucumber come from? Provenance, tracking back in time. That's a very simple example. It becomes even bigger when you've got, and I'm from India, if you haven't figured out the accent, made in India clothes, right? Bring it to New Zealand. Well, people obviously want to know, hopefully there's no child labor involved in this, or hopefully the part that is said made in India actually came from India. How do you track this? Well, there's no real proof, right? I mean, you trust the brand and made in India, so hopefully it's made in India. But this is how you track it, right? You can track back to where those materials that made that fabric, where those fabrics were put together by who, because again, everyone has an identity, right? And if that identity is on a shared ledger system where everyone has visibility, me as a consumer, I can go and see what that end product looks like. Vendors, suppliers, manufacturers, they all have visibility into that information, right? These are use cases that people are looking at doing. You've got some big manufacturing supply chain companies in this part of the world. How do they track that, right? Again, not so much tracking from an sensors and IoT perspective, but tracking from an authenticity perspective, right? Fonterra, right? Massive organization here. A couple of years ago, we had that whole thing with the milk powder in China. Just last week, right? There was another issue. We're talking to these guys, and Fonterra is pretty ahead of the curve. They're looking at how to do work in this space with authenticity on a distributed ledger system. Walmart, right? They're opening in China. I'm sure you've read it. Unfortunately, or for whatever reason, there's a lot of counterfeiting in that business. So Walmart now is using their barcodes and a distributed ledger system in order to track traceability of everything that goes on their shelves back into their system. So that's kind of the use cases that people are looking at, right? And those are the two main ones, that have stood out so far. It's fairly new technology, so it's the financial services side of things where people are looking at transactions and how these relate to one another and how we get rid of the middleman. And then there's the whole provenance and tracking and supply chain management. Remember, we talked about blockchain being one of the protocols, the one behind Bitcoin. That's essentially when people talk about that, they talk about it being blockchain 1.0. So very, very static. It's great in cryptocurrency. It transfers from point A to point B, and that specific task is what it does. Then came along a company called Ethereum. Ethereum is what people refer to as blockchain 2.0. So Ethereum did exactly the same thing as Bitcoin. They just added the ability to program code, right? So now they've introduced this concept called smart contracts. So a contract is nothing but a document which has some if-then conditions, and based on a certain requirement being met, that condition gets triggered, right? They introduced that logic. Why is that important? So now if I'm looking at maybe derivatives trading, or if I'm looking at some sort of event triggering an action, I can use smart contracts to monitor that. The moment it happens, I execute, and that execution can be on the blockchain with all of the results and the source and destination being recorded on that system. Again, because it's a shared ledger, because it's record after record from a read-only perspective read-only perspective, immutability is something which remains. Oh, sorry, probably over there. if you're wondering what is this example of a smart contract in this case, so this is, in the US, there's this whole concept of if you're healthy and you're exercising pretty well, we're going to give some benefits back to you from a health perspective, so your insurance premiums decrease. So here's a concept which they're exploring in terms of the health coin. So just like how we have mobile wallets, how do I have a health wallet, right? So I have a health wallet. It's got some health coins in there. I've set up a regime with my instructor or with my doctor. I'm following the regime. I meet my requirements. A smart contract executes, right? It does the checks. Hey, did this guy meet these requirements? Has he reached up to the stage? If yes, let me execute. It executes. It now drops in some more health coins into his health wallet. Also conversely, the other way, right? If he's not living up to it within the certain time, I'm going to deduct some health coins. Now that health wallet can easily tie into an insurance company, and guess what? Immediately, I can base premiums through a smart app like this, which is based on the blockchain.
Done.
Is that you? I think just probably open it up. Okay, there you go, done. Let's go.
Oh, no. Done.
How many engineers does it take to get PowerPoint going? So let's.
Okay.
No, wait.
Can you stop clicking? Yeah.
Okay, so while that's coming up, right? So the two biggest areas where we've seen this take off is financial services and manufacturing. What is being done in financial services? And you'll have all these slides. If you don't, let's connect after this. I'll send you a copy. What's happening in financial services? So let's take the biggest one, which everyone's doing, is what is called cross-border payments. So if you want to transfer some money to me, I'm based in Singapore. You transfer from New Zealand dollars to Singapore. That takes about 2 or 3 days at best case, right? So settlement time is long. Why? Because we have intermediate banks between yours and mine, and it needs to go through a process. Now, if I put this onto a blockchain system, if our banks are part of the shared ledger system where they have the right access or the relevant access to information, that settlement time is reduced to a few seconds, right? So it's not just operations and processing, but guess what? If there's ever an issue of a discrepancy, right, you've got a full ledger, so you can go back and have a look, right? If there's ever an issue, there is never an issue of fraud in this case, right? Because that is a ledger which is tracked, and everything's linked to one another. So there's no way for someone to go and hack into that system. In fact, if you're looking to hack into it, try hacking Bitcoin. It's got a $6 billion bounty on it today, right? So we're pretty sure about this technology, especially in terms of the cryptography. The next one is insurance, right? So, we've chatted a bit about this in terms of just claims. It's a pain in the butt, right? Even for myself to log, an insurance claim because, I know some guy's going to call me and he's going to heckle me and he say, oh, you not filed it correctly, or you can only get back this much. How do I avoid that as a consumer? And insurance companies are looking to do that, believe it or not. How do I move from this one big process into something which is decentralized and I can execute much faster? So that's another space, and you'll see in a bit. There is a solution with one of our partners, which is pretty cool in this. Post trade, so again a typical one where you execute a stock trade. I've experienced this quite often. We get shares from our company. You execute it when it's, the stock price is going high, like now at Microsoft, and then, it takes like 10 days for the money to come into your account, right? Again, going to multiple intermediate steps. How do I figure that problem through a shared system? And then the last one is know your customer. So a bit different, not working so much on the transaction side, but this is financial services looking at the identity side. I'll give you a simple example. Combank in Australia, right? You go to Combank, you sign up for an everyday account. They ask you for some identification. Great, not a problem. Tomorrow you want to do some stock trading, you go to ComSec, which is their securities and trading arm. Guess what? They're asking you that same information again. The after tomorrow you want to set up a business, there's a separate department, and they're asking you that same information, right? So how do I have a digital identity which can be represented across organizations, right? We're also looking at a system like the government of Estonia has started where every person in a country has a digital identity, and you control that information. So that identity is your personal asset, which has everything about you, from school records to hospitalization records, and you own the private key for that. So when you go to a hospital or an insurance company and you need to tell them that, hey, this is all my history, let me unlock just that part for you, right? So it's self-sovereign identity, which today is a bit hard to find, right? Because everyone knows almost everything about us the moment we go to one hospital or one place, right, as an example. Manufacturing, specifically supply chain, that's the other one where we're seeing a lot of this take off. And kind of few of the examples we talked about earlier. Want to move it?
What happened?
Stuck. So the first thing again is getting everyone represented on the shared ledger system. So everything having an identity of some sorts that's represented on the system. And you could do various ways, right? You could use IoT and RFID and all these different ways to track assets, and then you could take these attributes and represent each as a digital identity. So once I've represented as an identity, then I can do things like tracking, right? Where do these go? Where do they exchange hands? How do they come together in order to form a composite product? Important because now I can do things like certification, right? I can do things, and say, hey, this fabric was really made in this place. And then it also brings in the whole element of fraud. So that's a natural progression. So once you've able to digitize it and you're able to track it, then you're able to say, okay, this goods actually came from this place and this is the brand that's associated with it. So you're removing that whole element of counterfeiting. Sorry, I apologize. Do you want to move it? This is not.
Are you done?
No.
Next slide.
Yeah, sorry. Maybe next slide. This is not moving. Okay, so we've talked a little bit about what the hell this blockchain stuff is, right? It's distributed ledger systems. What are some of the use cases that we're seeing initially being explored? So what's Microsoft's play in it, right? So if you've seen across a lot of these technologies, Microsoft is trying to be that platform provider, right? So whether you want to do Windows, whether you want to do open source, whether you want to do something which we don't specialize in, we're trying to be that platform provider, right? Obviously, we've got Azure as our cloud, and Azure is great in terms of scale and elasticity. But then there's things like Azure Stack coming, right? Which even though it's 6 months, but it's essentially that same code in a box. So from an elasticity perspective. But then a lot of these protocols even run on containers, right? So Ethereum has a Docker container service. You could run this, if you wanted, and you saw the announcement last week of Docker's running on Windows Server. You could do that, or you could just stand up bare metal machines and run it, or you could just use a service fabric, that we've got in Azure, put that onto your on-prem and run it in that way. The idea is it doesn't matter, right? Hybrid, on-prem, off-prem, different people have different requirements. Most of this is open source anyways from a protocol perspective, so you could run this in your environments. The push for Azure is that this technology is fairly new. People don't want to go about investing so much in standing up environments, not knowing how it's going to take off. So for prototyping, use Azure, fail fast, fail cheap, the usual. What you see on screen over here is some of the work we've done with different partners. So remember I said Ethereum and Bitcoin, and Eris and Tendermint and all these different protocols. So we worked with these guys and we took all of that IP, we packaged them up into what is an ISV application on the marketplace. What that means is that if you want to get started with any of these protocols, single click deploys in about 25, 30 minutes, and you now have a node environment. Of course, when you're deploying, you select how many nodes you want, so that becomes your network. You could have public networks, which is like Bitcoin open for everyone. You could have private networks, which means that only the people you give access to can join, and those are the ones sharing that information. So all of this is possible just through single click. So these are real screenshots, and you'll get to see them in a bit from a product perspective. But again, the whole idea is there's a platform. We've taken out all that rack stacks, install, setup aspects out of it so that you can actually work on developing those end use cases. Few partners have gone the extra mile. What they've done is they've taken a particular use case. So this is Marketplace again. Just search for blockchain. So Block App Strato as an example. This is from a partner in the US called Consensus. They do a lot of work on the Ethereum protocol. They took that whole Ethereum node setup and they created a use case for identity on the blockchain, right? So that way, if you don't want to create your own use cases or develop your own code for identity, you can go and deploy them in a single click. Of course, this is where they're also trying to monetize some of it. So these ones cost compared to the previous ones, which are, does not involve any cost. I mean, the only cost you're paying obviously is for the compute and storage you use in Azure. So with that, we'll get Jay, to show us what this looks like.
Thanks, Richard. Yeah, hi, Jay. I'm just helping Richard today with the demos. And as you could see, he needed help with just clicking through the slides, so he definitely needs help with the demos as well. And yeah, and he also needed another person to blame in case the demo didn't work. So, okay, so I have the Azure portal open here, and I just have the some of the offerings available at the marketplace. So like what Richard was mentioning, right? So we have a one-click button, one button click capability to launch your portals, launch your network or your nodes off Azure. And the primary reasons why we see a lot of customers look at Azure is like, what Richard mentioned. One is the capability to do it in an agile fashion. And the other is also that, in a lot of cases, this is a distributed ledger. So you're in a consortium or in a public network, most likely in one of those two. 90% of the time you're going to be in one of those two. And you need to be sharing this with third parties you may or may not trust, right? So that's another reason to put this on a public environment like Azure so that it's easier for you to connect to the rest of the network. Right? So here, I just have the DevTest Labs environment open, and then I've created a lab environment, and then I can go in and create a virtual node for Bitcoin. So I'll go in and choose my base operating system. We'll go with Linux, so Ubuntu, and yeah, so I need to give so I'll say ignite demo, and then I don't want the standard A0. I'll go for a larger system. And then we have these pre-built artifacts, right? So based on which flavor of blockchain or distributed ledger I want, I can go ahead and choose that flavor. And like we said, we currently have close to about 3 dozen different options, and we continuously keep adding, right? So almost every week we have 1 or 2 more partners who put this up. And so what this lets me do is I can just go in and say, okay, I want it with Strato, and I'm done. So if I say create, in 10 minutes, okay, I need to give a seek password. So it's going to take less than about 5 minutes for me to get that system up and running. And then I have the node, then I can then have the node join the network, right? If I'm creating my own private network, I could do that, or if I'm going to be joining it into a public network, I would go ahead and do that. And this is as opposed to if you were to do the same thing on-prem, right? So we've worked with a few customers on a POC where it took them close to 2 days to set up the hardware and the networking, and then download the bits from some site or from somewhere online, and then set up a network, as opposed to doing this within 5 minutes. And then you also get all the benefits of the DevTest Labs, like you can do the auto shutdown and stuff, so that it keeps your costs in control, and it lets you pivot, right? So you could choose, like right now I've chosen Strato, and if you want to say, no, I don't want to do this, I want to play around with someone else's protocol, you could do that, right? You can, within a matter of minutes, you can shift back and forth and play around as you experiment with the technology. And so that's about the DevTest Labs, and then reverting back to the...
So when you guys get these slides, you'll see this, this is the next one. So while we're going and factoring in all these different vendors and partners and taking their protocols and putting it in Azure and allowing you to deploy it in a single click, we've also had a look and see where's the market heading, right? We don't think that it needs another distributed ledger protocol, so we're not building one, right? Unlike some of the other players. But what we think is that this needs to come into the world of cloud, because if I'm going to have all these transactions, guess what? I want to start doing some analytics on it. I want to do some reporting on it. Azure's got some pretty extensive capabilities there. How do I plug those in? We talked a lot about identity being, basic, private public key infras, right? Where do I host these keys, right? So we've got AD, we've got identity, we've got Key Vault. These are Azure services which exist today. If I do this in the world of IoT, so we've got a company in, this part of the world, they're looking at doing energy exchange. So solar panels collect, obviously solar energy. We have IoT sensors which measure that. Now, how does one solar panel exchange energy with another, right? So that so while the physics of that is already there existing, how do I transact that, right? Or how do I maintain those transactions? And this is where blockchain is coming in together with IoT. We also are, as you can see from these slides, we're not saying that, hey, one protocol is going to work over the other. We don't know where this market's going to head. So we're kind of hedging our bets. We're saying we're going to support all of them. But guess what? Today, if you're on one protocol, you can't talk to the other. That's a big problem. So we've built this gateway service, right, which is what we call Interledger. So one protocol on Ethereum can talk to another on Ripple, can talk to another on Eris. So that way, an insurance company and a hospital who might be doing work in isolation can come together when they've used this framework. And the other interesting thing is that whole middleware framework with these different protocols talking to each other, the hooks into different Azure services, that's going to be available, not today, as a service, right? Which means that you could be running on-prem in your environment, you could be running on AWS, you could be running anywhere, and you just want to leverage these blockchain capabilities as a service, you could do that. We've launched our first version of this, a couple of weeks ago at this whole DEF CON event, which is where a lot of the blockchain activities happen. And so you could go and build a complete Ethereum node and stand up a consortium environment. So let's have a look at what that looks like. Demo?
Oh, a demo, okay. Sure. So just to add to what Richard said, right? So the other thing we're also letting you do is, while all of this is on Azure today, right? So these partner solutions on Marketplace or elsewhere through Azure can also be deployed on-premise, right? So when we have Azure Stack later in 2017, that will let you use the same solutions and you can do the same thing on-premise, which is of interest to a lot of our financial services customers because they still prefer to keep it in-house, right? So this gives you the flexibility there. And the other thing is also that, this is the roadmap for where we are headed with blockchain as a service, right? So today we have these partner solutions which are more basic, but eventually we are looking at fully built services for particular particular verticals or even a few horizontal services as well. So those will be like fully built services which you can just consume like in a SaaS model of our platform. So what we have done is with version 1 of Bletchley, we now have this capability where you can create your own private network, right? So we give you the capability to stand up a private network. So this is a pictorial representation of that. And I will, yeah. So we have this on Azure. We have launched this template. So anyone who's familiar with Azure would know about the resource manager templates. So with a single click here, you could deploy this on the resource manager template, and it takes a little while. So because there's multiple nodes that are deployed. So I have one which is pre-deployed here. So if you look at it, they have like multiple minor nodes and also the transaction nodes, and I have them set up in my own VNet with subnets for each of these, and I can then I can now log. So this is my I've logged into the admin portal, and you can see the different nodes that are up and the block numbers of the transactions that they are doing. And if I refresh this, it should have an updated transactions, right? So what I've also done is, for this demo purpose, I've used this plugin called MetaMask to create wallets and show the transaction of Ether, which is the currency on Ethereum. This is an Ethereum-based network, so I can show the currency transfer here. So for what this lets you do is you can join your wallet to any of the networks, right? So that's the main Ethereum network, and then right now it's joined to my own private network that I have deployed on Azure. So if I can, like, for instance, now I have about 8,894.99 Ether. So let me just transfer some more Ether from the bank to here. So I've added another 1,000 Ether into this, and so this should get updated to, like you said, right? So it takes a while. It's not instantaneous right now. It takes a few seconds for the block to get mined and then the transfer to happen. So let's see. Come on.
So one of the things, right, what you're seeing here is you're seeing the graphical representation. So we talked about, you can go to Azure as an example. You stand up the nodes, right, which is nothing but the compute with the OS with the distributed ledger. And so that gives you a network, right? Then you've got to do something, right? That's when you've got to build use cases. Okay, let's say I want to do basic transactions. So transfer from point A to point B. So Jay's showing you, what we've done even at Microsoft. We've created a little plugin. I can give it some wallets and I can transfer. If you wanted to do this in your case, this is where programming languages come into. So smart contracts, they are programmed in a language called Solidity, right? So Microsoft, we've created a plugin for Solidity into Visual Studio. So the look, feel, as if you're doing C# or anything else, is just the same. So that's where, a lot of it is open source. So there's a lot of code available. So if you want to do your own crowdsourcing app or something of that sort, search ethereum.org, a lot of code snippets over there. So immediately, Solidity can go and help you to build these smart contracts. You can then use maybe Windows app or Xamarin or any of those capabilities to plug into Solidity and execute. And so we're showing you a very simple demo where it's a plugin doing that, but there's nothing stopping you from getting going.
So yeah, so you got the Ether here now from 1,894. It's now 2,894, and then I can now send. So I have another wallet created. So I put the address of the other wallet, and then I say send 100 Ether to the other wallet, right? And so yeah, and then it also puts in the transaction fee, which is the fee that I pay the miners for doing the transaction, right? So there's a whole bunch of Bitcoin miners, and the reason they do it is because they make money through this for the efforts of the mining that they do, right? So now this will get updated, whereby my account 2 gets deducted by 100 Ether, and then 100 Ether is transferred into the other account. So this is as we get refreshed. So like what Richard was saying, right? So this is a plugin, but you could create your own mobile wallet, which connects, or digital wallet, which connects to the Ether network. Sorry, the Ethereum network at the backend. And on top of this, you could also do smart contracts with Solidity, right? So you can have more logic and proof of work and things like that also built into the system, as we try and get it to be more complex. So I think it's yes. So yes, it has done the transfer from this account to the other one. And so what we have also done is we have the GitHub page, which has a lot of details on how you can do the whole thing, right? How do you set up the private network, and how do you set up these wallets? And you can also go ahead and do the coding in Solidity to create contracts and execute contracts. And switching back to
So those are the basics, right? But we've got partners doing some pretty cool things, right? So if we go back to the slides, probably skip this one. Let's talk. There's different kinds of partners. There's like big consulting firms, trying to pitch end to end of how we solve some of these processes. There's the integrators, which are hooking into a bigger financial services or manufacturing system, and then there's niche point products. Niche startups, right? Doing specific work. Libra, they're doing blockchain in the accounting space. Netkey is doing more in content management and blockchain. Consensus Ripple doing more in the financial services space. All of these that you see as brands, they're all on that marketplace app. Going to some specific ones next. Some specific ones. Here's a little company that started out of Canada, now based in Singapore. They've integrated into Terminus, which is a core banking system. And so every time there's a call needed to be made from a core banking system, from a transaction perspective, they've built that into blockchain. Why is that important? Because banks say, hey, we've got these big systems, it's difficult to integrate, difficult to introduce new technologies like blockchain. Here's a ready-made, easy plugin that they provide. The next one we've got is an integrator. Today, if your mobile wallets, at least mine, is purely used to pay for something. I can't do anything such as topping up, right? So if I'm running short of funds, how do I top up? How do I top up with maybe Bitcoin? How do I pay with Bitcoin at the pub? Or how do I even top up with crowdfunding, right? So this is an app which is built by one of our integrators to do those capabilities on a digital wallet. They've also extended those capabilities out to corporate wallets. Today, if corporate wallets are nothing but they're fairly dumb, right? There's no intelligence into it. But how do I have policies built into that corporate wallet? That's an app that's a capability they've built. And then they've also built the whole loyalty rewards sections, right? So in Europe, maybe not, but in Southeast Asia, as an example, people love loyalty rewards, right? From different grocers and vendors, and they like combining these rewards to get something of higher value. How do you track this, right? And how do you then relate it back to, the small businesses and so when the consumers are benefiting, making sure that businesses are not losing out. So loyalty rewards built on the blockchain. The next one we have is fairly Windows-centric. So these guys have built a Windows 10 app, and they're doing cross-border payments from that interface. So, very similar to what the use case Jay showed you, but now, transferring money between two countries in different currencies and doing that instantaneously. And then the last one is, a little plug on the insurance space. So here's a company. They're targeting specifically insurance. This is the first one that they've got out of the gate, which is on road travel. So you meet with an accident of some sorts. There's no injury to any person involved. How do you use telematics, right, to not telematics. How do you use, just pictures, upload what the damage to your vehicle is. Telematics points you to the nearest repairer. Once you're in that repairer, a checklist is passed in terms of what is the situation. That repairer then executes, in terms of fixing that situation. It's all hosted on a shared blockchain system between the insurance company, the group of repairers, and obviously the policy holders. It's validating what is your policy, what are you allowed to claim, and it's doing cashless transactions back to the repairer. So if you're ever stuck in that situation, it's all of your identity, all of that is happening on the fly in the back end without you having to, to execute any of that. And it's pointing you to the direction or the entities which are part of that shared system. A lot of examples, right? There's probably too much happening. There's people in Sweden who's taking the whole home loan process, that we have today. It probably takes a month and a half. It involves solicitors, it involves the bank, it involves insurance companies. Taking that whole process, putting it on a distributed ledger system. They go by the name of Chromaway, right? That's a Swedish company doing that, and they're reducing that whole process into a day, right? In fact, they do it in a few hours. They're just giving themselves a day, right? Speeding up, removing all of the fraud part, so that immutability is there, so that you can always go back and check. People are doing that with land tiles, right? So, ownership of land, if transfers between one and the other, what does that look like from a tracking system? So there's a lot of varied flavors, right? My thing to you, or my recommendation to you is, start small. Right? Look at something where, requires a technology like this, whether it's a digital identity space or whether it's something that, there's a question of trust between two parties, maybe just vendors and suppliers, whatever it works for your organization, and get a prototype going, right? The stuff doesn't really cost. If you go to the next slide, there's heaps of links over here which you can talk about how you can get started. Like all you need to do is, go to one of these use the ARM template, or go to the marketplace, deploy this. It stands up your network. Solidity is a client into Visual Studio. You're not paying anything for that client. Otherwise, stand up one in Azure. If you don't have that installed, it's pointing to your node. There's heaps of examples of just developing basic smart contracts out there, and just try it out and see, okay, what? Does this make sense for me, right? Does this, is it going to solve this particular pain point or not? And then there's obviously Microsoft people who can help you. This area is fairly new, right? It's taking off faster than we thought. I'll be honest with you, we never ever thought that the conversations we're having today, or we actually thought that the conversations we're having today we wouldn't be having until a good 6 to 9 months out, right? And it's great, but it's also scary, right, at the rate at which this new technology is moving. With that, thank you very much for listening. Thank you for coming over. Anyone has any questions, just come on up.